Hello guys, welcome to today's class. So today we'll be looking at limit and continuity. Yesterday I introduced limit and continuity and all that definition and all that has to do with limit and continuity. So today we'll be solving another problem on limit and continuity. So the question says investigate the continuity of this function. If f of x y equals to x raised power 3 minus y raised power 3 over x minus y at investigate the continuity of this function at 1 and 1. That means when x tends to 1 and when y tends to 1. So now, solution, let's investigate this function. When x tends to 1 and when y tends to 1, x raised power 3, y raised power 3 over x minus y. So now let's use direct substitution method to check if to investigate the continuity of this function. So applying direct substitutional method, x tends to 1 and y tends to 1. So we substitute what x tends to and what y tends to. And this will give you 1 cube minus y is 1 cube over 1 minus 1. This is equal to 1 minus 1 is what? 1 cube is 1 minus 1 over 1 minus 1. So this is 0 over 0. So this means that the continuity of this function is what? Indeterminate. We have to investigate if the continuity is what? Determinate. So if the answer to this continuity is 0, it means that the continuity is what? Indeterminate. So now, let's use another method by expansion. We have lim when x tends to 1 and when y tends to 1 of x cubed minus y raised by 3 over x minus y. So now, x raised by 3 minus y raised by 3 is still the same thing as x minus y algebraic expansion. If it's algebraic expansion to expand this, still the same thing as x minus y, all in bracket x minus y, all in bracket x squared plus x y plus y squared. So if you open this bracket, you arrive at this. So now we are going to replace this function with this. So now this will be x minus y x squared plus x y plus y squared over x minus y. So this is what we have. Say limit of when x tends to 1, when y tends to 1. So now what did you observe here? We have x minus y, x squared plus x y plus y squared over x minus y. So what do you observe here? These two can cancel out. So you can cancel out these two. And we are left with x squared plus xy plus y 2. Remember, we are taking the limit of this function when x tends to 1 and when y tends to 1. So you substitute the value of x and the value of what x tends to and what y tends to. So this is equal to 1 square plus 1 times 1 plus 1 square. This is equal to 1 square is 1 plus 1 times 1, 1 plus 1 square is 1. So our answer is what? 3. This is the answer and it is determinate. So we've succeeded in investigating the continuity of this function. If we investigated that if we use direct substitution, our answer will not be determinate. That means our answer will be indeterminate. But if we use by algebraic factorization, we'll get a determinate what answer. So please like, share, and subscribe. See you in our next class.